Hi everyone. So in this video we are going to study about implicants. So generally this topic is a bit typical and people find it difficult to study, and generally questions are also asked from this particular topic because this is one of the finest topic of this chapter. So we will cover this complete topic in this video only, and you will be very comfortable in the end of the video. So just watch till the end, right? So like this hierarchy I have written, these are all the subsets. Like there will be one Boolean expression, subset of that will be implicant, subset of that will be prime implicant, and then there you will get essential prime implicant, redundant prime implicant, and selective prime implicant. So this is the most important one, essential prime implicant. If some question is coming from this particular chapter, then it would be coming from essential prime implicant only. So essential prime implicant, this is known as essential prime implicant. So that is very important. We will study one by one everything. We will study all the implicants one by one. So first let's start with implicant. What do you mean by implicant? You know what is a Boolean expression, right? This is a given Boolean expression. So what do you mean by implicant? Implicant is simply a subset of the given function. So 0, 1, 4, 6, 9, 12, 15, that is there. So 1 is there, 9 is there, 12 is there, 15 is there. So it is a complete subset. G1 is a complete subset of function f. That means this is an implicant. This is an implicant because it is a subset. What about this one? 0 is there, 6 is there, 12 is there. So this is also an implicant. Implicant. But what about this one? 0 is there, 1 is there, 4 is there, but 3 is not there. So this is not a subset. That means this is not a implicant. So implicant is simply a subset. Now the same example can be asked in this manner as well. Basically here minterms are given and here the expression is written. So what you need to do? You need to find the minterms. So you can find the minterms of this. How will you write down the minterms? A and C will be there as it is, and all the expression of B and D will come. Basically without bar it will come. Then one bar, other is not bar. Then one is not bar, other is bar. Then both are bar. So in that manner we can write. So what will be your minterms? So I can write 8, 4, 2, 1. Now let's write down from here. Let's write down from here. So this is 0, 1, 0, 1, 0. 1, 0, 1, 0. That means 10. What about this one? 1, 1, 1. 1, 1, 1. 14. What about this one? 1, 0, 1, 1. 11. What about this one? 1, 1, 1, 1. 15. So 10, 11, 14, 15. 10, 11, 14, 15. All are there. That means this is an implicant. This is an implicant. Implicant. What about this one? Can I write down the expression? Yes, I can write down. A bar B C D plus A bar B C bar D plus A bar B bar C bar D plus A bar B bar C bar D bar, right? All the expression of C is coming here, C bar. All the expression of D is coming here, D bar. So let's write down the minterms. As far as I remember, it will come 0, 1, 5, 7, but let's try. For this one, what it would be? 0, because all are 0. What about this one? This would be 1. What about this one? 4 plus 1, 5. And what about this one? 0, 1, 1, 7. So this is also an implicant, right? This is also an implicant. What about this? This is given in terms of POS. So first I will write down the max terms. I will write down the max term. So component of D will come. Also component of D bar will also come. Right? So what will be the max terms? So max term will be 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0. Because this is POS form. So 0, 0, 1, 0, 0, 0, 1, 0, that means 2. 0, 0, 1, 0. Here 0, 0, 1, 1, that means 3. 2, 3. So what will be the min terms? Min terms will be a lot of numbers. 0 would be there, 1 will be there, 4 will be there, 5 will be there, 6 will be there, 7 will be there, 8 will be there. In that manner it will go till 12, 13, 14 and 15. And here only we can see that 4 is not there. This 4 is not there, right? So this is not an implicant. Not a implicant. Okay, so this is not an implicant. So this is the basic definition, just the subset has to be there. That is the meaning of implicant, right? Let's study about prime implicant. From here the important topic start. No one will ask you find the implicants. No one will ask you because there can be a lot of implicants, right? But let's study about prime implicants. So prime implicant basic definition is it is the best possible group. In one line if we need to say, I will just say it is the best possible group. Now you are not able to understand this. We will read these points later on, but let's start. Let's just say this function is given. What is this function? That minterms m 0, 1, 2, 3, 5, 7. You need to find the all possible prime implicants. So what you will do? What you will do? You will start with the best possible group, that means biggest group. Which is the biggest group here? Can I make a octet here? No, I cannot make a octet. Can I make a quad? Yes. Can I make another quad? Yes. Now there are possible pairs, right? This is one of the possible pair. This is also one of the possible pair. This is one of the possible pair. This is again more possible pairs are there. But you need to make sure that no pair should be made in between the biggest possible pair. That means if I make the pair between 1 and 5. So 1 and 5 both elements are there in this quad, right? So this is not a valid pair. If I make this pair which is 2 and 3. So 2 and 3 is available in this quad as well. This is quad 2 I am saying, and this is quad 1. So 1 and 5 is present in quad 2, the quad 1. In quad 1, this 2 and 7 is present in quad 1. 2 and 3 is present in quad 2. 1 and 3 is present in quad 2. 0 and 1 is present in quad 2, and this 0 and 2 will be present in quad 2. Already these are already present, so they are not prime implicants. Okay, these groups are not prime implicant. Look, this chapter has nothing to do with K-maps. Okay, don't confuse it with K-maps. It has nothing to do with K-maps, right? So here, like if I was drawing K-maps only, then only I would have chosen these two groups. Here prime implicants are these two groups only. So both conditions are same for this particular example, but for different examples it can change. We will solve a lot of examples. So let's try finding prime implicants in this particular group. So first I will make the biggest club, which is the quad I can see. Can I make another quad? No. Now I can make pairs, right? I can make this pair, 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 right? If I make single element, let's just say I make this element. So this is already there in the pair, right? This single element is already present in the pair, right? This single element. So I will not take single element in action. So first I will think of quad, then I will think of pair. That's it. Now, can you tell me how many implicants are there? Will you say 4 implicants are there? Sorry, how many prime implicants are there? Will you say 4 prime implicants are there? Because you will say that, sir, this is redundant. This is redundant with respect to K-map, but this particular topic has nothing to do with the K-maps. What did I tell you? First I will choose the biggest one, and then I will choose another one. What was the other condition? The other condition was that in between the groups you cannot make any other club. Let's just say I cannot make this club 5, 7. This club I cannot make. I cannot make this club 13, 15, because this 13, 15 club is there in the quad itself. Are you getting this point? This 13, 15 club is there in the quad itself, but this 12, 13, this I can take. Why I can take? Because 13 is there in the quad, but one of the element is not there in the quad. So the complete pair is not in the quad. If complete pair was in the bigger group, then I could not have taken it. So inside the bigger club, no further small clubs are allowed. No further small clubs should be there inside the bigger club. So whole club has to be there in the bigger club, then it will not be allowed. Otherwise it can be allowed. So one element is connected, so it is allowed. So how many prime implicants are there? 5. And in these 5, what all are? 4 pair and 1 quad. Can you write it down? Yes, I can write down. So first write down the quad. 5, 7, 13, 15. 5, 7, 13, 15. Let's write down the pairs now. 1 5 6 7 11 15 12 13. That's it. So, and what about 5 7? This will not be accepted because 5 7 is inside the quad, inside the bigger club. What about 13 15? 13 15 is also not accepted because 13 15 is also there in the bigger club, right? Let's see more examples. Let's take first, what is my target? See the biggest club. So biggest club, can I make a octet here? No. Can I make a 16 club? No. I can make a club of 4. So there you go. Can I make another club of 4? No. I can make club of 2 only. So 1 pair, 2 pair, 3 pair. Can I make this pair? No, this will not be accepted because whole pair was there in this quad only. Can I make this pair? No, I cannot make this pair. But how I can make this pair? Because one element is there in the quad, one element is there here. How can I make this pair? One element is there in the pair, but this element was alone. Now this element is alone, so this can make pairs with 10 and 8. 10 and 8. Right? Is there any other possible pair? Is there any other possible pair? No. Now you cannot say that, sir, that what is the need of this 8 12? Why are you taking this 8 12? In K-maps I would not have taken this 8 12, but here I will take. In K-maps I would not have taken this 5 7 13 15 as well, because this is redundant. Here I would not have taken 8 12 in the K-maps, but here I will take it. Why I will take it? Because I need to find all possible groups, making sure that no group is there in the bigger club. What is my target? My target is to make all possible group by making sure that no group is there in the bigger group. That's why I did not take 5 13 5 7, but I can take these because this element was alone. Here this element was already clubbed, but this element was alone. Here this element was already clubbed, but this can be clubbed with this one, right? Because both are not being clubbed in a single cell. If both were clubbed, in a bigger quad, then it would be a problem for me. But now it is not a problem. Slowly you will understand more points. Okay, slowly you will build it up. Now you might be thinking, sir, we are not able to grasp it, but slowly you will build. So one quad is there, and how many cells? How many pairs were there? 1 2 3 4 pairs were there. Am I missing out on anything? 1 2 3 4 4 pairs were there, right? So let's write down the quad first. 5 7 13 15. Now the pairs 12 13, right? 1 5 12 8. What else? 10 8 10. Okay, so these many pairs are there. Now you need to find maximum number of prime implicants in a 2 variable function. So 2 variable function means 4 cells. I need to find maximum number of prime implicants. If I write my 1 in this manner, so tell me how many prime implicants will be there? Only one, only this group. These groups will not be allowed. This group and this group, these groups will not be allowed, right? So what I need to do, if I remove this one, then how many groups I can make? 1 and 2. Can I make a group of single cell like this? No, because this cell is completely there in this pair. So only 2 groups are allowed. So here there are 2 prime implicants. Let's try thinking for 3. Okay, this I have already shown, but I should not show. So what will be our target? I should not make any quad. My target would be I should not make any quad. If I make a quad, then what will happen? If I make a quad, let's just say I write my ones in this manner. If I make a quad, then this would be one of the group, and then let's just say one is here, one is here. So this would be 2 and only 3 I am getting, because inside the quad I cannot make the pair. These two pairs I cannot make, and that would be my loss, because I need to find the maximum number of prime implicants. So how will I find that? How will I write down my ones? So I will start here. I will write 1 1. This will make me a pair. This one, this will also make me a pair. I can write one more 1 here, because again one more pair I will get. Can I write 1 here? No, because this will be a quad, so that I will ignore. Here I can write 1. Yes, I can write 1. Can I write 1 here? Because no, I cannot write, because this will make a quad. Can I write 1 here? No, I cannot write, because this will also make a quad, right? So, but this one will go alone, so I do not want that to happen. So what I can do, I can write this one here and then this one here. Is that a good thing? Okay. Is there any quad? My target is to avoid any quad, so no quads are there. So let's see how many prime implicants are there. 1, one of the element can be paired. 2, one of the element can be paired. 3, one of the element can be paired. 4, 5, one of the element can be paired, and 6. Now you will not say that, sir, both of the ones have been already paired. Why are you making a group? I need to find all possible groups. So this one has been paired with this one, has been paired with this one, and this one is there in this club, and this one has been paired with this one, and this one is there in this club. Are you getting this point? Inside a bigger quad, I was not able to make 2 clubs, because both of the clubs were there in the quad only. But if I am making cells, if I am making pairs, then I can make pairs anyhow. This is how I can make pairs. There you go. So how many were there? 6. How many were there? 6, right? Do you want me to write down the names? 0 1 2 3 4 5 6 7. Let's write it down then. 0 1 was there, 1 3 was there, 3 7 was there, 6 7 was there, 0 1 1 3 3 7 3 7 6 7, then 0 4 0 4 and 6 4, basically 4 6 you can say. So these many prime implicants are there. What about 4 variables? So intelligently you need to think, here there is no possible quad. I have adjusted the one in a manner that there are no possible quads. So let's write down the prime implicants. 1 2 3 4 5 6 7 8 9 10. Wait a second. Is there any pair? Let me think. Is there any quad possible? Let me see it. No, there are no quads possible. So I guess the pairs that we were making, that is fine only. I cannot see any quad here, because I wrote down the numbers thinking that only the 1 1 1 I can write. So if I write 1 here, that would be a quad. If I write 1 here, it would be a quad. So I wrote 1 1 1 in this manner. If I write 1 here, it would be a quad. 1 here, it would be a quad. Then I wrote 1 here. So in that manner I wrote. So 1 2. Actually there is no certain formula. That's why I am teaching this thing. No one will actually ask you the number of prime implicant. Okay, maximum number of prime implicant. But we have to solve in this manner. So 1 2 3 4 5, right? 5 and then 6. Wait a second, sorry, this one would be the 6th one. 6 7 8 9. This could be also possible. 10, right? 10 is there, this is 11, and this goes single 12. So 12 we have found. Did I miss anything? Am I missing anything? Yes, 12 I have found. 13th, where is the 13th one? There you go. This is the 13th one. 13. 13. 13 directly I am finding here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 13 I can directly find. Is there anything else? Am I missing anything? No. So in 4 variables I have seen 13. So what did you understand here? For two variables you got 2, for 3 variables you got 6, for 4 variables you are getting 13 here. So there is no certain formula. So if they are asking what is the maximum number of prime implicants, so they cannot ask. They will have to give you a function. Here they did not give any function here. They did not give any function. Directly I was putting 1 1 because my target was to find maximum number of prime implicant. So here I could find 2, here I could find 6, here I could find 13. And as far as I think, there are no quad. Hopefully I am not doing any blunder, because I have put these ones randomly, and you will not find these concepts in textbook as well, so you cannot even verify. So as per my understanding, everything is correct. I am getting in 4 variables, I am getting 13 prime implicants. So here there are 13 prime implicants. Here there were 6 prime implicants. So these are the maximum number of prime implicants which you can get. But this question will not be coming because there is no certain formula that in 2 variables 2 prime implicant is coming. I guess 13 is the correct answer. If someone is getting more than 13, then he can send me his solution on Telegram. I can check it. Okay, but I guess 13 is the maximum one. Okay, so now these kind of questions can come, that they will give you a function 1, 4, 6, 7, 8, 9, 10. Now you need to find their number of prime implicants. How many prime implicants are there? Before that, let's do the numbering. 0, 1, 2, 3. I should have done it before as well. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So let's start. Can I make a quad here? Yes, I can make 1. Can I make another quad here? Can I make another quad? No. 2, 3, 4, 5, and 6. So 6 you are getting. Okay. So 1 quad was there and 5 pairs were there. Let's write down the numbers. 8, 9, 10, 11. 15 or 11. 11, 15. Then 7, 15. Then 7, 6, 7. 3, 6, 7. And then 6, 4. 4, 6 you can say. Then this number, that is 5, 1. Sorry, 9, 1. 1, 9. 1, 9. Okay. So these are the possible prime implicants. Right. So these are the possible prime implicants. So these kind of questions can be coming in your examination. Okay. Let's study about essential prime implicants and the most important topic. What do you mean by essential prime implicants? So the group which cover at least one minterm that cannot be covered by other group. You are not understanding anything? Let me take some example and I will tell you how to find essential prime implicants. So what we will do? First we will mark up all the prime implicants. 1, 2, 3. Any other possible group is there? No. Now what I will do? I will go to the groups one by one. First I will go to this group. This is my first group. This is my second group, and this is my third group. I will go to this group and I will talk to each element of this group. So first I will go to this one and I will ask this one that, bro, do you have any other option than going with this one? That means, do you have any other option rather than staying in this group? Let's just say if one was there, then this would have been the pair, no? So if I had gone to this one and I would have asked that, bro, you are in the group 1, and this would have been, let's just say, group 4, that, bro, you are in group 1, do you have any other option to go without group 1? Yes, he will say, yes, I can go to group 4, right? But in this case, this group 4 is not there, right? I will go to this particular element, I will ask this one that where you can go. You can go with this one only, not this one. This one is also not there. So I will go to this one and I will ask you where you can go. So he will say, I can go only with this one. That means this element can go only with this. So if there is at least one term, there is at least, very important thing, if there is at least one min term that cannot be covered by other group, that means this min term can go with only this group only. So that is a prime implicant, essential prime implicant. So that is a essential prime implicant. Now I will go to group 2. So I will ask this one, bro, you are in group 2, do you have any other option? So he will say, yes, I have other option, I can go with group 1. I will go to this guy, I will ask him, bro, do you have any other option? He will say, yes, I have any other option, I can go with this one. So that means both are having other options. So this is not a essential prime implicant. Now in this group, I will go to this guy, he will say that I have the other option, but he will say I don't have any other option, I have only one option, which is this one. I have only one friend, he is having only one friend, which is this. So there are two essential prime implicants, What all are those? Group 1 and group 3, and there are 3 prime implicants. Which all 3 prime implicants were there? 0, 1, 2, 3. 3. This is 3. 4, 5, 6, 7. 3, 7. And 4, 5, 6, 7. 5, 7. Okay. So in this group, 3 can go with 2 and 7 can go with 5. In this particular group, 3, 7, which is this one, 3, 7. So if I write down all the prime implicants, then I can see that this 3 has a chance to go with 2 and 7 has a chance to go with 5. That means this is not an essential prime implicant. So what all are the essential prime implicants? That is 2, 3 and 5, 7. We will see more examples, it will be more clear to you. Let's make prime implicants now. Okay, in this example, can I make prime implicant in this manner? No. What did I tell you? First take the biggest pair. What is the biggest pair? Quad. There you go. Now can I make these pairs? 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 No, because all these pairs are there in the quad only. So only pair I can make is this. That's it. Now there are only 2 groups. This is one group. This is 2 groups. There are only 2 groups. That means there are 2 prime implicants. Right? How many of them will be essential prime implicant? So I will go to this group. I will talk with this one. Do you have any other option than going with this one? No. He will say, no, I have only one friend. Now I will go to this group. I will ask this one, do you have any other option? Without staying in group 2. Rather than staying in group 2, do you have any other option? He will say, yes, I have other option. I will go to this guy. I will ask him, do you have any other option? He will say, no, I don't have any other option. Because this is not possible. This is not possible. So he will say, I don't have any other option. So that means this one is also not having other option. Or you can go to this guy as well. If you ask this guy, bro, do you have any other option? He will also say, I don't have any other option, because this pairing or this pairing, these are not possible. I will go to this guy. I will ask him, do you have any other option? He will also say, I don't have any other option. So at least one I need to find. I just found that this guy don't have any other option. So I don't need to ask these guys. So both of them has to be essential prime implicant. So one by one I will go, and I just need to find one guy which is not having any other group. I just need to find one guy which has only one group. So that is this. Okay. 0, 1, 2, 3. 2, 3, 4, 5, 6, 7. 2, 3, 6, 7. 2, 3, 6, 7. So essential prime implicants are like those guys in college who belongs to only one group, right? They don't have any other friends. Like let's just say there is a group of 5 friends, right? So we take the name. Let's just say one guy is having the name of Ram. So Ram can have some other friends, but Sham, Mahesh, they are not having any other friends. So this is like essential prime implicant. That group is essential because those 4 guys are not having any other friend, or at least there has to be one of the guy who has only these 4 friends, not other friend, right? And in between the grouping is not allowed. Like there are 5 friends and 3 guys makes separate group and 2 guys make separate group. This is not allowed because that is not a good friendship, because in between the group there are groups, then there is an issue, right? So this is like you can relate it to friendship. 0, 1, 2, 3, 4, 5, 6, 7, 5, 7. Okay, let's solve this example. Can I make a quad here? No. So this group, this group, this group, and this group. 4 groups are there. 1, 2, 3, 4. Any other group are there? Any other group can you see? No. So 0, 1, 2, 3, 4, 5, 6, 7. Right? So 1, 2, 3, 4. 4 prime implicants were there. 4 prime implicants were there. What about essential prime implicant? So first I will go to this group. In this group I will ask him, do you have any other option? He will say, no, I have only one friend. I will go to this guy. I will ask 1, do you have any other option? He will say, yes. I am going into this group. This is the group 2. I am going to, first I went to 4, 5. When I went to 4, 5, I asked 4, do you have any other option? He said, oh, I have only 5 only. Then I am going to 5, 7. So I will go to 5 and I will ask him, do you have any other option? He will say, yes, I have the option of 4. I will go to 7, I will ask him, do you have any other option? He will say, yes, I have the option of 3, because 3, 7 is also there. So this is not a prime implicant, not an prime implicant, not a EPI. Now I will go to 7. Sorry, I will go to this group. I am talking to this group now, 3 and 7. So I will ask 7, do you have any other option than 3? Yes, he will say, yes, I have the option of 5. I can go. 7 has other option. Now I will go to 3. I will ask him, do you have any other option other than 7? He will also say, yes, I do also have other option than 7, that is 2. So 3 can go with 2. Here you can see 3 can go with 7. 3 can go with 2 as well, and 7 can also go with 5. So 7 has 7, 5 option, and 3 has also other option. 3 has option 2. So this is also not essential prime implicant. So these 2 are not EPI, not essential prime implicants. Now I will go to this group. I will ask this one, bro, do you have any other option? 3 will say, I have other option, that is 7. But 1 do not have any other option. This 2 is only, this 2 have only one friend, that is this 3. So this is essential prime implicant. So this friendship is important. These 2 friends are not that important, because 3 has one more friend, 7 has one more friend. So 3, 7 is not important. 5, 7 is also not important, because 5 is having one more friend, that is 4, and 7 is having one more friend, that is 3. So this is also not important, but these friends are important because 4 is alone and 3 is alone. 2 is alone. So these 2 are essential prime implicants. So in that manner you can think. Let's start with this one. 1 quad, you can see biggest pair. 2, 3, 4, and then 5. Should write down all the number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5. 5 prime implicants are there. In that, first I will go to 5, 7, 13, 15. 5, 7, 13, 15. So I can directly see that 5 has other option, 13 has other option, but 7 has no other option. 15 has no other option. So that is essential prime implicant. Then I will go and talk to other guys. Those are 1, 5. So I will go to 1, 5. So I will go to 5. He has other option, but 1 does not have any other option. Here this guy was not having any other option. So this is also essential prime implicant. Then I will go to this group 12, 13. So 13 is also having other option. So 13 is having this group, and 12 is also having other group, right? 12 is also having 12, 8 group, because 12 is also having 12, 8 group. So 13 also has other group and 12 also has other group. So this is not EPI, not EPI. What about this 12, 8? So 12 is having 13, 12 is having 13, and 8 is having 10 as well. So other group is also there. What is that? 8, 10. So 8 is having 10 and 12 is having 13. So this is also not EPI. And now I will go to 8. 8 is saying that I have 12, but 10 will say that I have only 8 only. So this is an EPI. So there are 3 EPIs and 2 which are not EPIs. So 5 prime implicants are there, and these are the essential prime implicants. So in that manner, if you are able to write down all the implicants, all the prime implicants, then it will be a cakewalk for you. You just need to see, okay, 1, 5, 1 is not having other friend, essential prime implicant. 13, 15 is not having another, 13 is having 12, okay, but 7 is not having another friend, so is essential prime implicant. So in that manner, you will never get the answer wrong, okay. Every time answer will be correct. Solve these questions on your own. Can you see a quad here? You can see a quad. Don't mess it up. You can see a quad. Which is that quad? This is the quad. This quad you can see here, right? Because a lot of guys would have messed it up. One quad you can see here directly. 2, 3, 4. That's it. So 4 prime implicants are there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So first pair is 0, 2, 8, 10. I can directly see that 8 is not having another option, 10 is not having any other option. So this is essential prime implicant. Then I go to this group 3, 2. 3, 2. 3 is not having any other option, right? This here, this 8 was not having any other option. Any of the element was not having other option. This 2 is having other option. This 2 is having this group, but 3 is not having any other group. So this is also essential prime implicant. Then I go to 5, 13. 5, 13. I can directly see that 13 is having other guy, but 5 is not having any other guy. This is essential prime implicant. And then I go to 13, 15. So I can see 13 is having other guy, but 15 is alone. So this is also essential prime implicant. So 4 prime implicants are there, all are essential prime implicants. Okay, let's see other example. Again, can I see a quad here? Certainly I can see a quad here. Do I see another quad? Do I see another quad? No. So 1, 2, 3, 4, 5, 6, 7 and 8. So 8 prime implicants I can see. All the pairs I need to make, all the pairs. So 8 prime implicants are there. Wait a second. 8, not 8. There you go. 9. Right? This can also be possible. 9 prime implicants are there. Are you able to see? 1, 2, 3, 4, 5, 6, 7, 8. And this is also possible, 9. Because this has different pair, this has different pair. Both are different pairs. So this is also possible. In between, both are not there. In between, these are not there. So we will write down all. Do I need to write down all? No, because if you write down all, it will take a lot of time in the examination. Now I will not write down all, I will just calculate the essential prime implicants. So let's calculate the essential prime implicants. So in the first group, I can see this guy is alone, right? This guy is alone. because this guy doesn't have any other option. So this is the essential prime implicant, which is 0, 1, 0 to 8, 10 only. 0 to 8, 10. This is essential prime implicant. So this group I have talked. Now I will go to this group. So first group I have talked. I am talking to second group now. So this guy has this option and this guy has other option. So second group I have talked. Now I will talk to third group. So this one has this option and this one has other option as well. Now I will talk to fourth group. So this one has this option, this one has this option, right? This one has this option, this one has this option. So other options are there. I will go to fifth group. So this one has this option, this one has this option, this one has this option, and this one has this option. So all other options are there. I am talking to this group. So I will go to this guy. This guy will say I have this option as well, and this guy will say I have this option as well. I will talk to sixth group. So this guy will say I have this option, and this guy will say I have this option. So sixth group I have talked to, and now I will talk to seventh group, which is this one. So I am talking to seventh group now. So if I talk to seventh group, so this one will say I have this option, and this one will say that I have this option. So seventh group I have talked to. Now I will talk to this group, which is eighth group. So if I am talking to eighth group, so this one will say I have this option, and this one will say that I have other option as well. So this is also not an essential prime implicant. Now which group is left? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, so I talked to all the group, but I did not write the name. This is 8 and this is the ninth one. So all these are having other guys. All these are having other guys. All these are having other guys. This is also having other guy. This is also having other guy. This one is having other group. This one is having other group. All are having two groups. All are having two groups. All are having two groups. All these are having two groups. This is also having two group. Only this guy was there, which was not having. So I have talked to all the guys. So this guy was having only this particular group. This element also has two group. This element also has two group. This element also has two group. But this guy was alone. So because of this is essential prime implicant. So only one essential prime implicant is there. Only one. So one essential prime implicant. So if someone asks you in this particular K-map, how many essential prime implicants are there? So only one is there. Okay. Let's see more example. Can I make a quad? No. 1, 2, 3, 4, 5. Any other possible pair is there? Any other possible pair is there? No. So this guy one is alone. This is going to one group only. This is going to two groups. I can see this is also, this one is going to this group. This one is going to this group. This one is also going to this group. This one is also going. Like I can see there are two boxes. No, I can directly see. This one is also involved with someone else. This one is also involved with someone else. This one is also involved here. This one is also involved here. Only this guy is not involved. Only this guy is alone and this guy is alone. I can directly see with the boxes. I can talk to individual groups. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 prime implicants are there. Out of these, which all are essentials one? 0, 1. And then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these two are essential prime implicants. So 2 essential prime implicants are there. That's it. Okay. So this is the concept of essential prime implicants. There are 2 more terms which are not usually asked. They are not usually asked in the examination, but let's study it. Redundant prime implicant and selective prime implicant. So what do you mean by redundant prime implicant? Read the definition carefully. Prime implicants whose each of the midterm is a part of some essential prime implicant. Each midterm should be part of some essential prime implicant. Okay, then only it will be called redundant prime implicant. let's take the example. So first I will mark all the prime implicants. All the prime implicants I am marking. Now I will mark all the essential prime implicants, which is this one and this one. Okay. So this group, look, there are 3 prime implicants, right? And there are 2 essential prime implicants. So now there is chance that one can be redundant prime implicant or one can be selective prime implicant. That's it. Okay. Now one would be there which could be redundant, or because out of 3, 2 are essential prime implicant. One I am not sure. It would be a redundant prime implicant or it would be selective prime implicant. So that I need to check. So what do you think? This is the group, no? 0, 1, 2, 3, 4, 5. So the group is 1, 5. Other groups are 0, 1. Other groups are 5, 7. Okay. So 1, this term 1 is involved with 0, which is an essential prime implicant, and 5 is involved with 7, which is also an essential prime implicant. So each term should be a part of essential prime implicant. Then only we will say this is redundant prime implicant. Are you getting this point? Each term should be a part of essential prime implicant. Now I will show you one example where there are redundant prime implicants. So let's see this example now. So first we will mark all the prime implicants: 1, 2, 3, 4, and this one can also come. So it will be 5, right? 5. So basically there are 5 prime implicants. Out of these, which all are essential prime implicant? You can quickly tell. If you go to this group, this guy is alone. If you go to this group, these guys are alone, or this guy is also alone. So, but these are the part of only one group only. And if you go to this group, this guy is alone. If you go to this group, you can see that this one is involved with this one, and this one is involved with this group. If you go to this group, this particular group, then you can say that this one is involved with this guy, and this one is involved with this guy. So both are involved in other groups. So this is also not essential prime implicant. So 3 essential prime implicants are there. Now rest 2 are left. Now these 2 will be what? Redundant prime implicant or selective prime implicant? That we need to check. Okay. So let's check that. So first I will go to this group. How I will check it? That I am telling. First I will go to this group, which is not an essential prime implicant. Now I am going to this group. I will talk to this element. So this element is connected to this group. So where I am already in this group only. I have gone to their home. This one is involved with this one. I will ask you where you are other involved. So he will say that I am involved with this guy. He is involved with this guy. Is this guy an essential prime implicant? No, this guy is not an essential prime implicant. I need to check about this group. This group is 12, 13. So I am checking about 12, 13. I am checking to 12, 13. So this is our 12. This is our 12. So I went to 12 and I asked you where you are involved. So 12 said that I am involved to 12, 8. Is this an essential prime implicant? Not. Is this an essential prime implicant? Not an essential prime implicant. So each term should be involved with the other group. So now I am talking to this guy. I am talking to this group. So I don't know where 13 is involved, but I am sure that 12 is involved with 8. And this group 12, 8 is not an essential prime implicant. That means it is selective prime implicant. This 12, 13 is selective prime implicant. Are you getting this point or not? Did you understand this point? Here we went to this guy, which is this 1, 5. So I went to 1 and I asked you where you are involved. So one side I am involved with 0, and then I checked about this group 1, 0. Is this an essential prime implicant? Yes. I am happy. Then I went to 5. I asked 5 where you are involved. So 5 said that I am involved with 7. Is this an essential prime implicant? Yes. So if this is an essential prime implicant, both elements are involved with other essential prime implicants only. That means this is a redundant prime implicant. But here I went to 12. I asked where you are involved. He is involved with 8, and 12, 8. It is also not essential prime implicant. That means, what do you mean by that? That means this is certainly not redundant prime implicant, because if it was involved with some other guy, let's just say if it was involved with 12, 7, and 12.7 was essential prime implicant, then I would go and talk to 13 and I would check where 13 is involved. But when I talk to 12 only, I got to know that 12 is involved with 8, which is not an essential prime implicant. So certainly this is selective prime implicant. So this is selective prime implicant. Now I will go to this group. I will go to this group. I will talk to 12. So I will ask 12 where you are involved. So 12 will say I am involved with 13. 12 will say I am involved with 13. Then I will check this group, and then I will get to know that this is also not an essential prime implicant. So I went to 12. I talked to 12 and I got to know that 12 is involved with 13. Now I am talking to these guys. So 12 is involved with 13. So I checked this group 12, 13, which is also not an essential prime implicant. That means this is also selective prime implicant. So two selective prime implicants are there. Look, you can drop redundant prime implicant and selective prime implicant if you are feeling that. I am certainly sure that you must have understood it. But like in the examination, you might get confused. But don't get confused in essential prime implicant, because that is very important. Don't forget essential prime implicant. That's why we are not going to see much example of selective prime implicant, because I don't want you to get into complexity. What is selective prime implicant? What is essential prime implicant? That I have only one friend. That you need to remember. Okay? That I have only one friend. That is selective prime implicant. That is essential prime implicant. For selective prime implicant, you need to talk to guys. I talk to 12. I know that it is involved with 13, but where it is other involved? It is involved with 8, which is also not an EPI. That means this is selective prime implicant. And when I go to this group, I got to know that this 12 is involved with 8, but it is involved with 13 as well, which is also not an API. That means both are selective prime implicants. Let's check more examples. First, I will make quad. 1 quad, 2 quad, and 3 quad. 3 quad directly I can see. More quad I can see, yes. 4 quad and 5 quad. All are quads only. So no pairs are there. All are quads. All are quads. All are quads. So 5 prime implicants are there. All are quads. I can see this one is alone. This one is alone, so this is essential prime implicant. When I go to this group, I get to know that this one is involved with this group. 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 So all are involved with some other guys, right? So this is not an essential prime implicant. When I go to this group, I get to know that this guy is alone, because this guy is involved with this one, but basically this group only. This is our group 1. This is our group 2. This is our group 3. This is our group 4. So when I go to this group 4, this one is involved with group 1. This one is involved with group 2. This is involved with group 3. But this one guy is alone. Right? And what is the other one left? This is our group 5. So when I go to this group, so this one is involved here. This one is involved to. This one is involved to group 3. This one is also involved to group 3. And this one is involved to group 4. So all ones are involved in some other group. So this is also not an API. So 3 APIs are there. Now, which all not are APIs? Basically, group 1 is EPI, group 3 is EPI, and group 4 is EPI. Now I will go to group 2 and I will talk to each of the element. So I went to 1, I went to this guy and I asked you where you are involved. He said that I am involved in group 3. He said that I am involved in group 3. This is our group 3. He said that I am involved in group 3. And group 3 is an API. So I am happy with the 1. I am happy with 1. Then I will go to this one. I will ask you where you are involved. He will say I am involved with this one will say that I am involved with group 1. And group 1 is an API. So I am happy with this one as well. Now I will go to this one. This one will say that sir, I am involved with this one is involved with group 5, and this one is involved with group 5, and this one is also involved in group 4 as well. This one is involved in group 5. You can directly see group 5 and group 1 as well. Sorry, group 4 as well. And group 4 is an API. So I am happy with this guy as well. I am happy with this guy as well. I will go and talk to this group. This will say that I am part of group 2, but I am involved with group 3 as well. And group 3 is an API. So I am happy with all the 4. I am happy with all the 4 that all 4 are involved in some other APIs. All 4 are involved in some other essential prime implicants. That means group 2 group 2, or I can directly tell their number, which is 4, 5, 6, 7. 4, 5, 6, 7 is redundant prime implicant, right? Let's talk about group 5. So I will go to group 5. I will ask this one, I am involved with group 4, essential prime implicant. I will ask this one, I am involved with group 4, essential prime implicant. I will ask this one, he will say that sir I am involved with group 3, which is also an essential prime implicant. I will go to this one, he will say that sir I am involved with group 3. So this is also an essential prime implicant. So all the elements are associated with other prime implicants. That means this group as well. Which is this group? 4, 5, 6, 7. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are also redundant prime implicants. So there are 2 redundant prime implicants, 3 essential prime implicants, and 5 total prime implicants. Okay. So this is the way of studying the complete implicants. This is being a long video. I know implicants are taught in a very small time, but I need to give you the in-depth concept because the questions can be coming from this particular topic. This is a very important topic. Okay. So I hope you must have understood everything. Now this is also an important point. Maximum number of essential prime implicants. In 2 variable, how I can get essential prime implicants maximum? This one and this one, if I replace this one and this one as like this, so this will be prime implicant, this will also be prime implicant, and this one has only one pair, this one also has only one pair. So here 2 essential prime implicants are there. If I replace one in this manner, so how many pairs I will make? 1, 2, 3 and 4. These 4 pairs I will make. So these 4 are the essential prime implicants. Are you getting this point? Because this one has only this chance, this one has only this chance. If I replace one in this manner, 1, 1, 1, 1, 1, 1, 1, 1. So what kind of pairing I can do? This is the possible pairing only. 3, 4, 5, 6, 7, 8. So 8 essential prime implicants are there. So alternatively, if I am placing 1 blank, 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 1 blank. If I am replacing alternatively, what does that mean? That means I am getting maximum number of essential prime implicant. So in 2 variables, I am getting number of variables is n. So I am getting 2 essential prime implicants. In 3 variables, I am getting 4. In 4 variables, I am getting 8. How I am getting it? Basically, if 4 variables are there, that means I can make 2 to the power 4 cells. I can make 2 to the power 4 cells. 16 cells are there. 2 to the power 4 cells are there. And if I replace 1 in half of that means 1, 3, and then this. So in 1 row, I am replacing in 2. Here also 2. Here also 2. Here also 2. So in half of that, I am replacing ones. That means 2 to the power 4 by 2. Here also what I am doing, total cells I am having 8, but alternatively I am writing 1. That means in these many cells I am writing 1. So if there are n variables, so how many cells are possible? 2 to the power n, and in alternatively I will write, so 2 to the power n by 2. So these many EPIs are there. So what is the total number EPI? Total EPIs are 2 to the power n minus 1 EPIs. Are you getting this point? So for n variable, total 2 to the power n maximum EPI. So if there are 4 variables, maximum essential prime implicant you can get is 8. What was the number of maximum prime implicants? That was 13. As per me, it was 13. Why it was 13? Because we made the table, right? Here we show it. It was coming out to be 13. I hope this is correct. Okay, because there is no way to recheck it. From nowhere you can recheck it, because like randomly we have to place, and this is the condition for maximum EPI, maximum prime implicants, I feel. But they will not ask you, because this is not a certain fact. There is no certain formula. You have to randomly place the ones. So I randomly place the ones, then I go to know that 13 prime implicants I am getting. So you can do the same. And you can try, if you are getting more prime implicants, then you can tell me on Telegram. I will also look into it. Okay, but this is not important. That was not important with respect to examination, but that is important because they can ask you the maximum number of essential prime implicants. Okay, now let's see. This would be our last topic of this particular chapter. So some examples of don't care we can see. So if don't care is coming, so I will use don't care only if it is helping me to make a major pair. Let's just say if I use this don't care, then I will have a group of 4. If I use these two don't care, then I will have a group of 4 again. If I use these two don't care, I will have a group of 4 again. Now why would I use these don't cares? There is no use of these don't care, right? And alone don't care will not frame any group. Like I will not say that this is a pair. Why this is not a pair? Because both are don't care only. I will not say this is a pair. I will not also take this pair. Why? Because this don't care is not helping me to frame a major group. Major group, what is the major group here? Major group is quad. So this don't care is helping me only to make a pair. So I will not take it. Are you getting this point? Till now in the GATE history or in any examination, the questions has not been asked on don't care. Okay, in any examination, don't care question did not come. But what if it comes? If it comes, you need to solve in this manner: 1, 2 and 3. That's it. Because these two don't care are not helping you to frame a major group. And if you are framing a group here, that would take both don't cares, and that I don't want. Let's just say if I was having one more don't care here, one more don't care here. So would I frame this major group? Which major group I am talking about? This major group. Would I frame this major group? No, this is not a prime implicant. Not a prime implicant. Why? Because of this property. Not because of this property, sorry. Because of this property. Because alone don't care will not frame any group. So in this particular group, you are only having don't cares. So that is not a prime implicant. This is not we want. So how many prime implicants are there? 1, 2, 3. 3 prime implicants are there. 3 prime implicants are there. Now, how many of them are essential prime implicants? Let's check that. So this don't care is considered as one only. So this one has only one chance, that is this group. So this is essential prime implicant. If I go to this one is having only one chance. If I go to this group I am talking about, this particular group. This is our group 2, this is our group 1, and this is our group 3. So 1 and 3 are essential prime implicant. But if I go to group 2, so group 2 will say that this one will say I can go here, this one will say I can go here, this one will say I can go here, this cross will say I can go here. So all are having other opportunities. This one is having group 1, this one is also having group 1, this one is having group 3, this cross is having group 3, right? So this is not essential prime implicant. So 2 essential prime implicants are there. So what is this group? Group 2. So I will go to group 2, I will talk to this one. One will say I am part of group 1, which is essential prime implicant. This one will say I am part of group 1, which is an essential prime implicant. This one will say I am part of group 3, which is an essential prime implicant. And this cross will say I am part of group 3, which is an essential prime implicant. So all the numbers are part of essential prime implicant. That means one redundant prime implicant is there. So this is redundant prime implicant. Okay, because all are part of essential prime implicant. So 3 prime implicants are there, 2 essential prime implicant and 1 redundant prime implicant. And that is the complete concept of implicants. I hope these are enough examples for you. We will take more examples in the assignment problem, which is the next video. So I will show you the assignment now, and you need to solve it on your own, and then you need to watch the next lecture. Okay, so I will show you the assignment. Do solve it on your own, because that would be a very good practice of you, and then you will be very comfortable by the end of this particular chapter. I would say in this chapter we have covered logic gates, Boolean algebra, then we saw the representation techniques, and then we saw the K-maps, which is a minimization technique. So these 4 topics we have covered in one chapter only. So I will show you the assignment, or I can assignment PDF also will be posted. So from PDF only you can see the assignment. Okay, I'm not going to show in the video. From PDF only you can see the assignment and solve it. Okay, then let's meet you in the next session now.